Okay, what's up guys, it's Magnetic here.
I'm your teacher.
And today we are going to be doing a new series called Do You Work or Be a Jerk?
And we've got a famous YouTuber to help. So, what are we going to be doing this episode?
What's that? What's that?
What we're going to be doing?
Sorry, I've got some in.
What?
We're
going to do some revision?
I'll be back in a second.
Revision? You're going to help me? We're going to do revision?
I'll be back in a second.
Revision?
I'll be back.
I thought you were going to...
Go.
Are you going to do the...
I'll be back.
You're going to do the revision?
I'll be back. Suckers.
He's not coming back, is he? Alright, he's gone. I've been to check. He's definitely gone. He's definitely not coming back. He's watching Gotham. So you've got to put up with me. I'm the talented one anyway. So what I figured we would do is we would go through a list of things that would be really useful for you to revise for your forthcoming mock examination. So here's the list. Ta-da! I'm going to go through each one in turn and give you a little bit of detail about it. Flowcharts. Flowcharts, I can't really teach how to use flowcharts at this stage. The important thing that you need to know about flowcharts are the symbols. You need to know the start symbol, the stop symbol, the process symbol, so that's when the computer program does something, it prints or it calculates. The decision symbol, the lines that come from the decision symbol. If you put any lines on, you must label them. You must put yes or no or true or false or something like that. Otherwise, you will lose a load of marks. Really simple way to gain a load of marks. You must put arrows on your lines. If you don't put arrows on your lines, the flow chart will not show you which way the data, the program is flowing. So if you put arrows on your flow chart, it will show the flow of data. Lossy and lossless compression. Compression is where you take something digital and you make the file size smaller. So for example, you could record an audio or a video like I am now. I'm recording in full HD. I probably won't give it to you in full HD because it'll take ages. I want a smaller file size for you to download, for you to stream. If I were to give you the audio or this video in a smaller resolution, you would lose some data. That is called lossy compression. You've lost some of the pixels, you've lost some of the sound quality, you've lost some of the data. Computers are quite clever. Well, they're not. Computers aren't clever. The computer will remove data that thinks that you won't notice, but you cannot recreate the original document. If you take a 720p version of this video, you cannot make it 1080. You just can't. There isn't the original data there. You can make it bigger, but it will be fuzzy, it will be pixelated. You cannot recreate the original. If you are using lossy compression, you have lost some of the data. If you are using lossless compression, you can recreate the original, just like in your Python controlled assessment. You are taking a load of words, you are reducing them to something substantially smaller. We're just indexing them, we're just keeping a record of the indexes. But by using the original word list, we can recreate it. So lossless means you can recreate the original document. Just like zip files. If you zipped up a Word document, the last thing that you want when you unzip it to read the document is half of the images are missing or every third word is gone. that's useless. You need to be able to recreate the original. That is lossless compression. Security. Do you see what happened to test score? How many accounts were hacked? How many? Was it 20,000 or something like that? How much money was taken? Security is really important. Your operating system has security built into it. Even if it's Windows, it has security built into it. It can protect you from being hacked, and more importantly, if you are hacked, it can stop that information, that data that the hacker gets from being understandable, from being useful to them. Obviously, the first port of defense, the first line of defense, is to have a username and a password, so nobody can get in without the username and password. But what is increasingly happening is hard disks are automatically encrypted. They are garbled up, and there's a special key, special digital computer key that unlocks the data when you log in. If you forget your username and password, that data on that operating system hard disk has gone forever. You just cannot get it back with that key, which is great. If somebody nicks your computer and they don't know your password, they can't get that data from your hard disk because the operating system's encrypted that data. Even on a desktop home computer, you can have different levels of user access. For example, this computer here, I've got admin access. I've got local admin access to my computer. So if I install anything or if I want to do anything clever on it, I can do it without being nagged at. Okay. The boy, he does not have an account that has admin access on it. On his account, he's got a user account, so he can log in and he can load Word and he can do certain things on it, but he can't install software. He can't delete things. You know, on Windows, when you try to install some software, and on a Mac as well, and you don't have admin rights, you get this thing pop up into your face and it takes over the screen and it says, you are not allowed to install this. And on a Mac, I don't know what it's like on Windows, but on a Mac, you can click, I have the admin password, and you click on it, and you type the admin password in, and it installs it. But if you don't have the admin password, you are not allowed to install it. Also, you can set files to not be deleted. There's a list. If you right-click on a file, you can go into the properties, you can tick it and say, you're not allowed to delete this file. People using this computer cannot change this file. A bit like the shared area at Woodham. You just get read access on it, but I get write access to it. IP addresses, MAC addresses. For your mock exam, you need to be able to discuss the difference between IP addresses and MAC addresses. Now, top tip here is, in an exam, if you are asked to discuss the differences, write about one, write about the other. If what you have said is different, you've identified the differences. So what do we know about IP addresses? Well, we know that when you connect to a network, you are assigned an IP address. You may be given the same IP address that you had last time. You can set it so, if you're in charge of the network, you can set it so when a device connects, it has a fixed IP address, so it gets the same one every time. Like, that's really useful for printers and servers on your network, but they can change. They can change. IP addresses can change. If you reboot your router and then connect to your broadband again, you may get a different IP address. MAC addresses, on the other hand, can't be changed. They are assigned by the manufacturer to a piece of hardware. For example, if you connect to Woodham's Wi-Fi, you'll get a different IP address every single time on your phone. But the Wi-Fi can pull your MAC address of your device. So if we want to ban you, yeah, okay, we can ban your username and password, but you could use somebody else's. You could take somebody else's username and password and try and log in with that. Whereas if we take the MAC address of your device, and we can get that when you connect to our Wi-Fi, we see your MAC address. We take that MAC address of your device, which is unique. There's no other piece of equipment in the world that has or ever will have that address. We can take that MAC address and we can say, that device, that MAC address, is not allowed on our network. And you can't change it. You can't change your MAC address. You are banned. Well, your device is. It also would be useful to you to know how long IP addresses are, how long MAC addresses are, how IP addresses are written usually, how MAC addresses are usually written in terms of number bases, and when you would use a MAC address and when you would use an IP address. Failover. Asda. Epic fail, Asda. What the flip were you thinking? Seriously, did you see what happened? Their IT systems completely failed across the whole country, and they had no backup system in place. So shoppers were just standing in queues for a couple of hours while these systems were rebooted and brought back up online, which is appalling. It's absolutely disgraceful. Even if you just think about how much money Asda would have lost just in those 2 hours, let alone the damage to their reputation. It's just stupid. It's epic fail, Asda. They needed a failover system. There's something called redundancy. Redundancy tends to mean that you don't need something anymore. If you are ever made redundant from your job, hopefully you won't be, that means your job's not needed by the organisation anymore. In computing terms, redundancy isn't always a bad thing. If in terms of data it is. If you've got redundant data, you've got a repeat of data in a database, that's not good. That's not good. So data redundancy isn't good. But hardware redundancy can be quite useful. In the event of failover, what happens is, like with Asda, when their system goes down, it automatically switches to an identical system. So you've got two systems in place. And the backup system kicks in. A bit like you see on movies when there's a power cut in a hospital and the emergency lights kick on. It's exactly the same thing for computers. But you've got a whole system, a whole mirror of a system. So if a shop or a bank computer system goes completely offline and just drops, the mirrored system, on the event of failover, automatically kicks in. It's expensive. You need to buy double the equipment. You need to maintain double the equipment. But if you think about how much money could be potentially lost, that's not actually necessarily a bad thing. Programming languages. Python is a programming language. I hope you already knew that. It's a high-level programming language. I hope you already knew that bit as well. But what does that actually mean? Well, it means it's based on the English language. So it's written in a way that humans can understand. We write code in English-ish. The syntax is English. If, then, while, for, print. These are all English words. We can follow the structure when we read Python. High-level programming languages are generally machine independent. So I could take my high-level programming language, which I have made on an i7 processor, and I could put it on an i5 processor and run it, and it will work in exactly the same way. You can also take high-level programming languages and often run them on different operating systems. For example, I can happily run Python and Java on my Mac. They are portable. What happens is when I run Python, it is translated into machine code. So at that point, it becomes processor specific or machine specific. So at work, if I take a Python program I've created and I run it, it's translated into machine code which that particular computer understands. If I bring that code home and I run the same high-level Python program, it's converted into machine code for my Mac, but it will be different machine code because my Mac works differently to the computers at school. One command in Python, so if you print brackets, quotes, hello world, that's going to give you many, many, many lines of machine code. Machine code is not readable by humans. It's binary. Programs that are already in machine code form don't need to be translated, which is good. So if you've got an executable, it's already in machine code, it will be faster because you don't have to have that translation stage, but it won't be portable. There are different ways to translate machine code. I recommend you do a little bit of reading on compilers. Systems architecture. I'm sure you are fully aware of the fetch, decode, execute cycle, but let's have a quick recap. Instructions programs that are currently running, like my screen recording software, are stored in RAM. The more RAM you've got, the faster your computer will work, because it will hold more of these running instructions, these programs. When the computer needs to do something, the processor fetches instructions. It doesn't actually fetch them from RAM directly, it fetches them from the processor cache. The processor cache is really fast memory, really close to the computer, and the more you can keep that filled up with instructions ready for the processor, the faster your computer will be, because the processor will not run out of the next lot of instructions. If it does run out of instructions, if the processor is working faster than the cache, if the cache cannot fill up quick enough for the processor still hungry, it's a bit like Pac-Man, it needs to get these instructions, it starts pulling them from RAM directly, and RAM is much slower than cache, so really that cache needs to be kept full for your processor to be working at the optimum speed.